Question for this week is, what determines emission intensity?
As a reminder, emission spectra graphs wavelength in nanometers against intensity. The intensity is what we will be looking at this week. In an emission spectra, the peaks and the dips between them tell us a lot about the substance. In our data, one thing we notice is that the peak for green is higher than the peak for red. The reaction that occurred involved equal amounts of dye and activator being mixed together. The energy produced by that reaction was equal for both dyes and caused them to fluoresce. If equal amounts of energy are being put in, but different dyes have different intensities, that means something other than the energy put in must be at least in part affecting intensity.
We noticed that for the most part, green absorbed higher energy photons than red did. Green seemed to absorb between 200 to 300 nanometers, much more than the energy needed to produce one green photon, which is closer to 500 nanometers. This suggests that the electron is getting excited to a very high energy state, and multiple photons are released as the electron relaxes.
Meanwhile, absorbance lambda max for red is only slightly shorter than emission lambda max at 570 versus 610, making it more likely that only one red photon is produced. This would cause the emission intensity for green to be higher than red.
This can be related to finance. If Gina takes in a large amount of money, she can buy more things with that money. Meanwhile, if Rose takes in a smaller amount of money, she will be able to buy less things.
One reason this might happen is green dye is made up of only hydrogen and carbon. This means the bonds are not very polar, so the electrons are more evenly distributed. This would mean it takes more energy to get to a higher energy level because the electrons are at a lower density and therefore farther apart. But it also means that the energy levels would be more evenly spread out, like shown in the energy level diagram for green. Red contains more types of atoms, which would cause some bonds of higher polarity, increasing electron density and making electrons closer together.
In conclusion, emission intensity is affected by both energy input and dye structure. You can see in this graph that as energy runs out and input goes down, emission overall goes down. However, the emission intensity of the dyes relative to each other has much more complex causes, such as bond types in the molecule.